Tesla Bot Gen 3 could become the world's most popular household helper for under $10,000 by next year. With an upgraded hand dexterity and new AI learning capabilities, it will smoothly handle tasks like cleaning, carrying items, and assisting the elderly. Elon Musk asserts that Optimus has 4 key factors that make it unbeatable by competitors. Why will Tesla dominate the family robot market in the coming years? Before we begin, please help us reach 4,600 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. 1. Stability and mobility. Let's begin by comparing the Optimus robot with Figure 02 to explore aspects that were once considered the biggest challenges: stability and walking ability of humanoid robots. Just 6 months after Tesla announced the Optimus project, in August 2021, many experts doubted whether Tesla could overcome the technical barriers that even Boston Dynamics had spent over 15 years overcoming. However, instead of seeing these as insurmountable obstacles, we realized that every challenge is completely feasible in the age of modern AI. When it comes to stability and walking ability, one of the biggest barriers is balance, something traditional algorithms have always tried to address by calculating movement from multiple sensors, adjusting actuators, and processing unexpected situations in real time. That's why early versions of robots like Honda's Asimo or Boston Dynamics Atlas often had to be tethered with safety ropes during testing to prevent them from falling. But that was before reinforcement learning AI came along and changed the entire game. Previously, robots learned to walk through inverse kinematics algorithms, which required precise calculations of each joint, contact surface, and reaction forces at each moment, referred to as the zero moment point, ZMP. This approach consumed significant computational resources and lacked adaptability in real-world environments. A 2019 MIT report showed that the ZMP model had a delay of up to 200 milliseconds when processing collisions or uneven terrain, leading to instability. Many robotics experts even criticize Tesla for choosing a humanoid design instead of wheels, which are much simpler for maintaining stability and saving energy. However, thanks to modern sensors like the IMU, Inertial Measurement Unit, similar to those in smartphones but with 10 times higher accuracy, combined with AI-powered learning through millions of simulations, achieving stable bipedal movement is no longer difficult. A 2023 study by NVIDIA showed that a robot could achieve reliable walking after just 25 million simulated steps in a virtual environment, equivalent to several weeks of continuous training. The key is that when the simulated environment closely mirrors reality, robots only need a few hours of fine-tuning to operate stably in the real world. The years that followed proved this analysis was accurate. AI not only helped robots learn to walk and stand, but also taught them to run, play sports, dance, and even move quickly across rough terrain. Boston Dynamics Atlas took more than a decade to learn running and jumping. Meanwhile, Figure 02, just 18 months after development, was already walking naturally at a speed of 1.3 meters per second. In contrast, the early Optimus prototype in 2022 only reached speeds of under 0.5 meters per second and had a stiff gait often likened to a cartoon character dumped. Figure 01 was no better. It could walk, but had difficulty standing still, frequently adjusting its weight between the 2 legs as if running in place. However, things changed dramatically within just 1 year. The Figure 02 version released at the end of 2023 walked confidently, reflexively responding to being pushed, and even managed to sit down and stand up smoothly, something that was out of reach just the year before. Meanwhile, Tesla hasn't released any new videos of Optimus since early 2024, but Elon Musk confirmed in a live stream that the internal version can now walk around the factory, deliver objects, and use its hands for real tasks. With the same rapid development Tesla demonstrated in the electric vehicle sector, the real-world capabilities of Optimus might have already surpassed what the public has seen. Today we can watch videos of humanoid robots from China, like GR1 from Fourier Intelligence, or Walker X from UB Tech, not only walking, but also running, jumping, and even flipping. GR1 has reached a speed of 2 meters per second on a treadmill, which is equivalent to a fast human walking pace. The democratization of bipedal movement shows that the competitive edge in the humanoid robot field no longer lies in basic capabilities like moving. Even low-cost robots like Unitree H1 $3,800 can maintain balance when pushed or walk over sloped terrain. Once again, please help us reach 4,600 subscribers. This is important for us to stay motivated. Thank you. 2. Dexterity and Skill. When Tesla first announced the Optimus humanoid robot, some robotics experts openly criticized the decision to use human-like hands. They argued that it was an amateur mistake, as simpler tools like clamps or suction cups would be cheaper, easier to produce, more reliable, and require less control software, all of which are already widely used in factories. However, this argument overlooked an important factor. Humanoid robots are not optimized for a single task like industrial robots. They need to be capable of performing nearly everything that humans can do. Therefore, the requirement for the robot's hands is to be flexible enough to grip a metal pipe, while also being delicate enough to lift an egg without breaking it, presenting opposing challenges of force, precision, and control. Previously, these tasks often required complex control algorithms and manual programming, something experts wanted to avoid. However, they underestimated the potential of modern AI. Thanks to neural networks trained through simulations, tasks that once required sophisticated programming techniques can now be solved automatically. For example, Optimus can perform actions such as picking up a water bottle, typing on a keyboard, or folding clothes, tasks that once required specialized robots and complex software. In recent demos, Optimus demonstrated the ability to self-adjust grip force using AI when handling objects with varying weights and fragility, a challenge that older robot systems struggled with. Mechanically, the issue used to be that finger actuators were too large to fit inside the robot's hands, forcing designs to place them in the arms and use tendons to transmit movement, which introduced reliability risks due to tendon stretching. But recent technological advances have miniaturized and increased the efficiency of actuators, especially thanks to Tesla's tiny brushless motor technology, and AI now allows the robot to self-correct to compensate for tendon stretching, turning a disadvantage into an effective solution. The current version of Optimus is the second generation, with hands featuring 11 degrees of freedom, compared to just 4 in the first version. Tesla is developing a third-generation hand with 22 degrees of freedom, operated by an advanced tendon system, a significant improvement over modern robots, which typically have 5 to 10 degrees of freedom. Some competitors have quickly copied or improved upon Tesla's open design, notably the Magic Lab in China, which modeled nearly the entire hand of Optimus just 6 months after Tesla released the blueprints. Even the Figure 01 model from the startup Figure AI now boasts a hand with 19 degrees of freedom, enabling it to fold clothes and use scissors like a human, a step very close to the goal of making robots multifunctional. However, comparing who is better at this point might be misleading, as the pace of improvement is too fast. Within just 2 to 3 years, even newer startups like Sanctuary AI or Fourier Intelligence could develop highly dexterous robot hands if they truly invest. What matters now is not who has the slightly better design, but which company can scale production quickly, improve reliability, and integrate the most comprehensive AI systems. Tesla has a significant advantage because they produce actuators for both electric vehicles and robots, are strongly funded, and have a top-tier AI team. In 2024, Tesla spent over $1 billion specifically on developing the Optimus robot while optimizing their supply chain through gigafactory plants, allowing them to significantly reduce robot production costs compared to smaller startups. Nevertheless, the rapid development of competitors has led to dexterity becoming an increasingly democratized factor, no longer a unique advantage of Tesla. It's clear that the race in humanoid robotics is no longer just about mechanical engineering, but about scale, reliability, and AI, where every small step could shift the market balance. 3. Household robots. Initially, many experts predicted that household robots would take several more years to become a reality. Compared to the structured environment of factories and repetitive tasks, training robots to handle the numerous and ever-changing situations in a household was seen as a much more complex challenge. At the same time, factories were willing to pay much more for robots that work almost 24/7, whereas everyday consumers are highly price-sensitive. As a result, most believed that industrial robots would take the lead, and household robots would have to wait. However, the reality is changing faster than expected, and Tesla, with its Optimus Gen 3, is directly challenging all these old assumptions. Optimus Gen 3, Tesla's latest humanoid robot generation, is not only a leap forward in both mechanics and AI, but also a gateway to the era of household robots. Elon Musk has repeatedly emphasized that the ultimate goal of Tesla Bot is not limited to factories but to bring a universal housekeeper into every home. With Gen 3, that is becoming more achievable than ever. 3 key factors driving this breakthrough include the groundbreaking development of large language models, LLMs, the strategic value of data in the home environment. First, LLMs like GPT-4 have completely transformed how humans interact with robots. Now, Optimus can understand natural language instructions, ask clarifying questions, comprehend context, and turn vague desires into specific actions, a major hurdle for household robots in the past. Second, although the home environment is more complex, it is also a priceless training data mine. The everyday interactions, unexpected situations, and diverse user behaviors that Optimus Gen 3 records in the home will help Tesla build a more flexible and intelligent AI than ever before. This is the same strategy that has helped Tesla excel in autonomous vehicles, collecting real-world data at scale. Third, the network effect will play a key role. The more Tesla Bot Gen 3 units deployed in homes, the smarter the AI system will become by learning from this rich dataset, creating a continuous improvement loop. Tesla could easily subsidize Optimus through massive profits from industrial robots, aiming to rapidly dominate the household robot market. Just as they sold electric cars at lower prices to gather FSD data, this time, Tesla is willing to do the same with Optimus to gain a competitive edge in training AI for robots. The race for household robots is coming faster than anyone predicted, and Tesla Bot Gen 3 is the clearest proof of this. It's not just a machine, it's the beginning of a revolution in human-AI interaction right in people's homes. 4. Manufacturing. Mass production is the final frontier. When we first began researching this topic, we believed that Tesla's manufacturing capabilities would be the trump card in the humanoid robot race. After all, they are manufacturing experts. Tesla currently produces over 2 million vehicles annually, and is the only company in the world to have successfully implemented the GigaPress 6,000 to 9,000 ton casting technology, reducing the number of car body parts from 171 to just 2 to 3 main pieces, shortening assembly times, and cutting labor costs. Even if someone were to surpass Tesla in robot technology, they could still scale up much faster and regain the lead. This seemed reasonable, but we have begun to doubt that assumption. It should be clear. Tesla has invaluable manufacturing expertise. They've invested over $3 billion into automated manufacturing facilities, including the Tesla operating system software, which controls the supply chain and operates industrial robots. However, manufacturing robots is fundamentally different from manufacturing cars, and, in many respects, even simpler. A humanoid robot stands about 173 centimeters tall and weighs 56 kilograms, which is only 5% of the size and weight of a Tesla Model Y, approximately 1,900 kilograms.
I would say probably less than $20,000 would be my guess. Okay. The potential for Optimus.
Tesla is turning the game into its own by integrating solid-state batteries into Optimus, a move that slashes production costs by up to 70%. With solid-state battery prices now as low as $50 per kilowatt-hour, mass-producing humanoid robots at record low costs is finally within reach. Tesla is rapidly advancing toward its goal of dominating the $10 trillion robot market. So how will the Gen 3 Tesla bot lead the industry with this breakthrough battery technology? Before we begin, please help us reach 4,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot Gen 3, Tesla EVs, and the latest news. Why is solid-state battery the ideal choice for Tesla Optimus Gen 3? Compared to electric vehicles, humanoid robots have far stricter requirements for battery weight, size, and safety. According to official data we've collected, Optimus currently uses a battery pack with a capacity of around 2.3 kilowatt-hours, allowing for approximately 8 hours of continuous operation. However, to scale production to millions of units, Tesla must overcome 3 major challenges. The current 4,680 lithium-ion battery is too heavy, around 8 to 12 kilograms. The charging and operating time is still insufficient, and there is a fire risk when the robot operates in various dynamic postures. These are precisely the issues that solid-state batteries, known for being lighter, having higher energy density, and offering superior fire resistance, are capable of solving. Solid-state batteries replace the traditional liquid electrolyte with a solid one, boosting energy density to 400 to 500 watt-hours per kilogram compared to 270 watt-hours per kilogram in 4680 batteries, while nearly eliminating the risk of fire. Furthermore, they allow for much faster charging, potentially under 15 minutes, and have a lifespan 2 to 3 times longer than conventional lithium-ion batteries. Under ideal conditions, a solid-state battery could help reduce Optimus's total weight from 55 kilograms to under 50 kilograms, while extending its continuous operation time to up to 12 hours, a significant advantage for robots working in factories or assisting humans in daily environments. Signs that Tesla is seriously pursuing this path are becoming increasingly evident. In 2022, Tesla filed a patent related to lithium metal batteries using nanocoatings to stabilize solid electrolytes, aiming to improve durability and reduce short-circuit risks. In 2023, Tesla also recruited several engineers from top solid-state battery companies like Solid Power and QuantumScape. Notably, Elon Musk has repeatedly emphasized, "We will do everything to reduce weight and increase the performance of the robot. Battery optimization is mandatory." These statements, combined with Tesla's vertically integrated manufacturing strategy, suggest that the company may develop and apply solid-state batteries in upcoming Optimus Gen 3 or Gen 4 prototypes. If successful, this would represent a revolutionary leap forward. Optimus could operate longer, become lighter, and far safer. A lighter robot would result in more agile actuators, improving mobility, heavy lifting, and task precision. Higher energy density would also allow Tesla to design a more compact battery pack, freeing up internal space for more sensors or advanced processors. Equally important, robots with shorter charging times and longer battery life would become extremely economically viable when deployed at scale in manufacturing environments. However, the road to mass-market solid-state batteries is far from easy. Currently, solid-state batteries remain expensive, costing between $200 to $300 per kilowatt-hour, roughly 4 to 5 times more than Tesla's in-house 4680 lithium-ion cells, which are around $60 per kilowatt-hour. Scaling up production is also a major hurdle. Even industry leaders like Toyota, Solid Power, and QuantumScape are still in the experimental phase, without stable commercial production lines. Additionally, the manufacturing defect rate for solid-state batteries remains high due to their sensitivity to temperature, humidity, and the complex microstructure of their materials. With its advantage of full control over the supply chain and manufacturing, Tesla could become the first company to commercialize solid-state batteries for humanoid robots, especially if the rollout begins in small batches and gradually scales up. The most realistic scenario is that Tesla will test solid-state batteries in premium Optimus Gen 3 versions between 2025 and 2026, before applying them widely in Generation 4. If Elon Musk and his team can overcome the cost and mass production challenges, a solid-state-powered Optimus will not just represent a technological leap, but could usher in a new era for humanoid robots where they become lighter, smarter, and as common as electric vehicles are today. As tech giants around the world race to develop humanoid robots, battery technology could become Tesla's strategic weapon for market dominance. Rivals like Figure AI or Agility Robotics still rely on conventional lithium-ion batteries and lack Tesla's deep in-house battery development or supply chain control. Even Xiaomi's Cyber One, which leans heavily on expressive interactions, has not shown any progress in solid-state battery development. This puts Tesla in a prime position to commercialize solid-state batteries in humanoid robots, enabling it not only to surpass U.S. startups, but also to erect technological barriers against Chinese and Japanese competitors. If Tesla succeeds in integrating solid-state batteries into Optimus at a reasonable cost, the impact will go far beyond technical performance. Operational costs will drop significantly, thanks to battery lifespans that could stretch across decades, minimal maintenance, and ultra-fast charging that maximizes uptime. Once the monthly rental cost for a robot falls below $1,000, Optimus could become an appealing solution not only for factories, but also for service providers, logistics firms, and even households. As global labor shortages and rising wages continue, a robot that is lighter, more durable, safer, and cheaper to operate than a human could become a disruptive force in today's labor market structure. As you know, Tesla's success in robotics cannot be separated from Elon Musk's radical design philosophy, one that relentlessly pursues absolute simplicity. Musk once said,
The best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong.
This principle is embedded in every Tesla product, from eliminating the gear shifter in the Model S to integrating the battery into the vehicle's chassis. For Optimus, Elon is pursuing a design that can be mass-produced like a car, meaning every gram of weight and every material detail must be optimized. Solid-state batteries, with their compact, lightweight, and safe characteristics, are the next inevitable step toward realizing the goal of producing millions of robots per year in the most efficient and streamlined way. However, if the plan to adopt solid-state batteries fails, Tesla could face serious setbacks. The robot's weight may remain too high, limiting agility, especially for tasks like lifting, stair climbing, or working in tight spaces. Worse still, if a startup or major company like Toyota, Honda, or a Chinese firm gets there first with commercialized solid-state batteries, Tesla could lose its leadership position, something Elon Musk has repeatedly warned is unacceptable for the company's long-term strategy. In the long term, if Tesla succeeds with solid-state batteries, it could pave the way for even more advanced generations like lithium-sulfur batteries, or even self-adaptive battery systems that adjust energy output based on the robot's activity. With the massive amounts of real-world data Optimus collects, Tesla could train AI not only to operate robots efficiently, but also to optimize energy usage contextually, something no traditional battery company has ever attempted. This would be a revolutionary advantage, transforming Tesla robots from mechanical machines into intelligent, adaptive systems that can respond seamlessly to real-world conditions. Once again, please help us reach 4,500 subscribers. This is important for us to stay motivated. Thank you. What advantages would Tesla gain by mastering solid-state batteries for Optimus? In our assessment, if Tesla masters solid-state battery technology, it will be the key to significantly elevating Optimus. First, it would greatly reduce the robot's weight while improving its overall performance. Solid-state batteries are not only lighter, but also offer a higher energy density compared to traditional lithium-ion batteries. According to research, solid-state batteries can deliver twice the energy within the same volume. For a humanoid robot like Optimus, this means a lighter body, more agile movement, and improved energy efficiency. A lighter robot will be able to move more easily, perform complex tasks, and reduce the load on motors and mechanical components. A simple example can be seen in electric vehicles. Tesla has leveraged battery technology to reduce vehicle weight and optimize performance across its models. The Model S, with its minimalist design and battery pack integrated beneath the floor, helps lower overall weight, thereby improving driving range and acceleration. Similarly, Optimus could operate more efficiently if solid-state batteries help cut its weight by 20 to 30%, similar to how modern EVs reduce mass to achieve better performance. A lighter robot not only moves faster, but can also operate continuously for several hours without needing to recharge. Second, the extended battery lifespan will significantly reduce long-term operating costs. One of the biggest advantages of solid-state batteries is their ability to withstand up to 10,000 charge cycles, 3 times more than traditional lithium-ion cells. This not only extends the robot's service life, but also lowers maintenance and battery replacement costs throughout its lifespan. If Optimus is equipped with solid-state batteries, the reduced maintenance requirements will enable Tesla to offer robot services at lower operating costs. Take electric vehicles again as an example. Tesla has reduced maintenance costs by optimizing battery performance. The Model 3 can operate for 500,000 to 1 million miles without major battery issues, thanks to Tesla's advanced battery technologies. If Tesla applies the same level of innovation to Optimus, the company could substantially lower robot maintenance costs, making the product more attractive for long-term leasing by businesses. Reducing maintenance and battery replacement expenses over the robot's lifetime could drive rental prices below $1,000 per month, a much more accessible level compared to competitors like Honda or Toyota, who still face high production costs for humanoid robots. Third, supply chain control and lower production costs. Tesla has built an exceptionally strong and independent battery supply chain, covering everything from lithium mining to cell manufacturing and energy management system optimization. This allows Tesla to avoid reliance on external suppliers like CATL, Panasonic, or LG Energy, increasing production flexibility and reducing supply chain risks. If Tesla masters solid-state battery technology, it can manufacture these batteries within its own factory network, reducing production costs and accelerating product rollout. In the EV industry, Tesla has already demonstrated the benefits of controlling the battery supply chain, allowing the company to lower costs and offer competitively priced electric vehicles like the Model 3. Tesla has outpaced rivals such as Rivian and Lucid Motors by producing EVs more cost-effectively thanks to its in-house battery production. Likewise, controlling solid-state battery technology for Optimus could bring the production cost of each robot down to around $20,000, enabling Tesla to produce millions of humanoid robots at lower prices and with a strong competitive edge. Fourth, deep integration with robot design for space and performance optimization. Solid-state batteries can be integrated directly into the robot's frame, similar to how Tesla embeds battery packs into the floor structure of its EVs. With a minimalist design approach, Tesla can save space for other critical components, such as motors and control systems. This not only enhances structural rigidity, but also improves mechanical performance, enabling the robot to move faster and more nimbly in tasks requiring precision and agility. Tesla has already applied this design philosophy in EVs, especially in the Model S and Cybertruck, where the battery is placed beneath the vehicle floor to maximize space, improve performance, and enhance durability. Applying the same principle to Optimus would make the robot more efficient, energy-saving, and better optimized for complex robotic features. Finally, Tesla holds a major advantage in data and AI for energy optimization. One of the most significant benefits Tesla can leverage if it masters solid-state batteries for Optimus is the ability to collect and analyze data from millions of robots. Appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun. Tesla's Optimus Gen 3 may ultimately mark the beginning of a new era, where humanoid robots are as common as smartphones are today. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. And thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.